Good day, friends, viewers. You're welcome to Brilliant Minds Academy. Today we'll be considering calculations of oxidation number. Oxidation number has been a problem to some students because they do not understand how compounds are named in chemistry. This video has been designed to provide solutions to that because we'll be unleashing different tricks and rules guiding oxidation numbers. Now we are going to consider the meaning of oxidation numbers, the rules, as well as questions and answers. Alright, let's start from the meaning. Oxidation number refers to the electrical charge possessed by a substance. Sodium Na, for example, has no charge, hence the oxidation number is 0. Na+, on the other hand, is an ion and has an oxidation number of +1. Ca2+ will have an oxidation number of +2. Now let's go to the rules of oxidation number. I'm going to be giving you 4 rules for oxidation number. The first one states that the oxidation number of elements in the uncombined state is 0. The second rule is the oxidation number of monoatomic ion is equal to the charge on the ion. For example, Fe2+ we have an oxidation number of +2, while S2- we have an oxidation number of -2. Then going to rule 3. Rule 3 states that the sum of the oxidation number of each element in a radical is equal to the charge on the radical. An example of radical or polyatomic ion is Cr2O7 2- and S2O3 2-. They both have an oxidation number of -2. Then moving to the last rule, that's rule 4. The sum of the oxidation numbers of each element in a compound is equal to 0. This is for compounds that do not have charges, that is, compounds that are not radical, e.g. H2SO4. We need to take note of oxidation numbers of some elements that are very important in chemistry. Starting from group 1 elements, they all have an oxidation number of +1. Group 2 elements have an oxidation number of +2. Group 3 elements have an oxidation number of +3. Oxygen is -2 except in peroxide, where it is -1, and in higher oxides, where it is -0.5. Examples of peroxide include sodium peroxide, calcium peroxide, etc. Sodium peroxide is Na2O2. An example of higher oxides is given in the video, NaO2CaO4. The halogens have an oxidation number of -1, chlorine, fluorine, bromine, iodine. Hydrogen is equals to +1 except in hydrides, where it is -1. Example of hydride is sodium hydride, that's NaH. Apart from this, we also have calcium hydride, aluminum hydride, and so on and so forth. So without wasting much of our time, it is time for us to get into the video in depth, that is by treating different questions under oxidation numbers. Example 1. Calculate the oxidation number of sulfur in H2SO4. H2SO4. Now, the first thing to do in this case is to remember our rule number 4. You equate it to 0 because it is a compound that doesn't have a charge. Then splitting the elements, we have H2 plus S plus O4 equals to 0. Now, the oxidation number of hydrogen is +1, that of oxygen is -2, so you impute it, but don't forget to multiply the oxidation number by the number of atoms present. We have 2 atoms of hydrogen there, we have 4 atoms of oxygen. So going by this, we are going to have 2 plus S minus 8 equals to 0. Collecting the like terms, sulfur will be equals to 8 minus 2, and at the end of it all, we are going to have sulfur to be equals to +6. Hence, the name of the compound is tetraoxosulfate 6 acid. Now, let's go to the next example. Example 2. We have to calculate the oxidation number of carbon in CaH open bracket HCO3 close bracket 2. Now, the first thing to do is to equate it to 0 because this has no charge. Now, if I were you, I will break down this compound by opening the brackets with 2 to have CaH2C2O6 equals to 0 before splitting the elements and their number of atoms. Now, the next thing is to impute the different oxidation numbers of the known elements. Calcium is +2, hydrogen is +1, oxygen is -2. So you impute it and multiply it by the number of atoms present. So we are going to be having 2 molecules of carbon, 2 atoms of carbon in that expression, that equation. Now the next thing is, this will give us 2 plus 2 plus 2 carbon minus 12 equals to 0. Then we have to collect the like terms. This will result to 2C equals to 12 minus 4. 12 minus 4 should give us 8. Then we have 2C equals to 8. Dividing both sides by 2, we have 8 over 2, and that is 4. So this compound is calcium hydrogen trioxocarbonate 4. So we can see that calculating of oxidation numbers gives us a clear explanation to how compounds are being named. Now to the next example, we want to calculate the ON of sulfur in S2O3 2-. We have to consider rule number 3 here by equating it to the power, to the charge. So S2O3 equals to -2 before splitting the elements. Now we have to know that oxygen is -2. So impute the value of oxygen and multiply it with the atoms. We have 2s plus -2 into bracket 3 equals to -2, which is the charge. This will result to 2s minus 6 equals to -2. Then collect the like terms. We have 2s equals to -2 plus 6. Then we're going to have 2s equals to 4. The next thing is to divide both sides by the coefficient of sulfur, that is 2. Then s will give us 4 divided by 2. Then we are going to have the oxidation number of sulfur to be +2. Hence, this is called thiosulfate ion. Then the last example for today, we want to find the oxidation number of sodium in sodium peroxide. In this case, we were not given the formula. Hence, your ability to know formulas of compound is very important. Sodium peroxide is Na2O2. So this is not having a charge, it is not a radical, it is a compound, so you equate it to 0 before splitting the elements. So Na2 plus O2 equals to 0. Now we have to remember the rule guiding oxygen, that oxygen is always -2 except in peroxide where it is -1. So oxygen will be -1 in this case, not -2. Then we have 2 sodium. Yes, because we have 2 atoms of sodium there. That will be 2Na plus -1 into bracket 2 equals to 0. This will give us 2Na minus 2 equals to 0. Then collecting the like terms and dividing both sides by the coefficient of sodium will result to having sodium to be equals to 2 divided by 2, which is 1. So the oxidation number of sodium in sodium peroxide is +1. Alright guys, so take these ones as assignments and try and see if you really understand the concept of oxidation numbers. The assignment should be submitted if you feel like in the comment section, and I will do well to answer to this. Thank you so much for watching, guys. This is once again Brilliant Minds Academy. Please like, share, subscribe to this channel, give it a thumbs up, and click on the notification button so that you can get first-hand information of our videos. Thank you very much for watching.